Hi everyone, this is the second video for section 5.1 on divisibility rules. Okay, so in this video, we're going to be talking about the different tests for divisibility that come with different numbers. So a lot of these you should have, well, some of these you should have seen before. Some of them are really standard. For example, a number is divisible by 2 if it's even, right? And we just know this from right when we learned this, the basic operations in elementary and middle school. So a number is divisible by 2 if the number is even. That makes a lot of sense. So actually, as we go through these divisibility rules, I'm going to underline them as we go through them, and then we're going to check this number down here, 186,372. So we're going to go ahead and do this example 3 as we kind of go along. So I recognize this is kind of out of order, but that's okay. Okay, so we know that a number is divisible by 2, the number is even. So let's check if 186,372 is divisible by 2, and clearly, right, it is. So 2 divides 18637. Well, that's not correct. 2 does divide 186,372 because, right, the last digit's a 2, so it's even. One thing to note, another way to say the number's even is if the number ends in 0, 2, 4, 6, or 8. It ends in an even digit. Okay, a number is divisible by 3 if the sum of the digits is divisible by 3. So you may or may not have heard this one before. If you haven't done a lot of math, you may not have heard this. This is kind of a trick that only some people learn in their schooling, but it's really helpful and useful that a number is divisible by 3 if the sum of the digits is divisible by 3. It's a nice little handy trick. So let's see if 3 divides 186,372. Well, we just add up the digits, 1, 8, 6, 3, 7, 2, and we just add these up in any way we want. Because we have the commutative property of addition. So I'm going to add the 8 and the 2. So the 8 and the 2 is 10. The 3 and the 7 is 10. And then we have a 1 and a 6, which is 7. So this is 27. And we know that 3 is divisible by 3. We do know that 3 is divisible by 3. We know that 3 divides 27, meaning that 27 is divisible by 3. So 3 divides 27, so 3 divides this number. Okay, so now the test for 4. So there's 2 different tests for 4. So it's divisible by 4 if it's divisible by 2 twice, right? And that makes a lot of sense because 4 is just 2 times 2. So if it's divisible by 2 twice, or the last 2 digits form a number divisible by 4. So this is the test that's going to be a lot more useful because although we know that this number that we're dealing with down here is even, it's kind of hard to see if it's divisible by 2 again without just dividing it by 2. So the second test, the last 2 digits forming a number divisible by 4, is going to be a lot more helpful, in my opinion. So we have 4. We want to see if 4 divides 186,372. So we're trying to look at the last 2 digits, so 72. And we want to see if 72 is divisible by 4. So we can just divide it if we want. Yeah, so we can look at 72. Divided by 4. 4 goes into 7 once. With 3 left over. And then 4 goes into 32 8 times. So you don't have to really do this all the way, but just enough so that you know, right? You could stop when you get to 32 and be like, I know that 4 goes into 32, but it's not that much extra work to see that it goes in 8 times and just write it down. So yeah, 4 divides 72. So we have that 4 divides 186,372. And the motivation for this test is that 4 right? We are only looking at things in the ones place and the tens place. So we kind of ignore everything in the hundreds place on, and that's because 4 divides 100. 4 divides 100 because 100 is 4 times 25. So 4 divides 100, and therefore, as we saw in the product property, then 4 will divide any multiple of 100. And 186,300 is a multiple of 100, right? 186,300 is 1,863 times 100. So it's a multiple of 100, and then 4 will divide, therefore, any multiple of 100. So that's why we only have to look at these last two. It's because we know that everything from the hundreds place on will always divide 4 because of that product property. So that's kind of where this test comes from. Okay, a number is divisible by 5. If the number ends in a 0 or 5, this is something that you should definitely have seen before. We use this all the time to look at 5s if it's divisible by 0 or 5, because we're in a base 10 system. So in this case, it's pretty clear this number does not end in a 0 or 5. So we have that 5 does not divide 186,372. Okay. So now let's look at 6. So 6 is a little bit different. A number is divisible by 6 if the number is divisible by both 2 and 3. So yeah, this is a little bit different. This is a little bit different, but it makes sense because, well, 6 equals 2 times 3. So if the number divides 2, if the number is divisible by 2 and it's divisible by 3, then yeah, it should work. 2 and 3 have no overlap, right? The only things that if you listed out the multiples of 2 and the multiples of 3, the only multiples that they have in common are the multiples of 6. And that's a really nice thing because it makes this divisibility test a lot simpler, because all we have to do is go back here and say, okay, we know it's divisible by 2, we know it's divisible by 3, so therefore it's divisible by 6. Okay. You can see that there's not a divisibility test for 7 up here, and that is because if you want to check if something's divisible by 7, there is a test, but a lot of times it's just easier to divide by 7, just because it can be a little complicated. So if we want to check if 7 divides 186,372, right, like I said, it's just easier, and a lot of times, to divide by 7 and see what actually happens. So 7 goes into 18 twice, with 4 left over. 7 goes in 46 6 times, with 4 left over 6 times, with 1 left over, goes into 17 twice, with 3 left over, and 7 does not divide evenly into 32, it only goes in 4 times. So this has a remainder. So this is remainder 4. So we can write this as 7, right? Well, we're about to write it over here, right? 7 does not divide this number because it doesn't divide evenly, because 186,372 divided by 7 has a remainder. I remember the definition said that there should be no remainder for this divides to be satisfied. Okay, so that's 7, right? There is a test, but it's usually a lot easier to just divide by 7. Okay, so now we're at 8. So a number is divisible by 8. So this one is going to look really similar to 4. So remember that a number is divisible by 4 if you can divide by 2 twice, because 4 is 2 times 2. So similarly, a number is divisible by 8 if you can divide by 2 3 times, because 8 is 2 times 2 times 2. Again, or the last 3 digits of a number form a number divisible by 8. Okay, right, so this is really similar to 4, and again, this comes because, okay, so I'll write it up here for 4, so 4 divides 100. And so that's what tells us we only need to look at things lower than the hundreds place. And we also have that 8 divides 1,000. So we need to just look at everything lower than the thousands place is why we have these two last tests for 4 and 8. So we're trying to determine if 8 divides 186,372. So we need to look at, does 8 divide 372? So again, we can just divide 372 divided by 8. 8 goes in to 37 4 times with 5 left over, and then 8 goes into 52. We know that 6 times 8 is 48. So 6 minus 48 with 4 left over. So again, this has a remainder. So we know that 8 does not divide, write that a little bit better, 8 does not divide 372, so that means that 8 does not divide 186,372. Okay, next we'll look at 9. So a number is divisible by 9 if the sum of the digits is divisible by 9. So you can see that this is really similar to the test for 3. Right, a number is divisible by 3 if the sum of the digits is divisible by 3. Similarly, a number is divisible by 9 if the sum of digits is divisible by 9. And right, this makes sense that these two would be related because 3 times 3 is 9. So again, we've already added up these digits, right, when we tested for 3. So if we want to see 9 divided by 186,372, well, we also know that 9 divides 27. So because 9 divides the sum of the digits, right, 27 is actually 9 times 3, so 9 and 3 divide 27, so that means that 9 divides this whole number. Okay, the last test that's listed here is being divisible by 10, and right, we should all know that something's divisible by 10 if the number ends in a 0, and for our motivating example down here, it's not end in a 0. So 10 does not divide this. Okay, so those are our basic divisibility tests. Those should be the ones in the book. The book actually, I don't think covers all of these. So it has 2, 5, 10, 4, 8. Oh, it does. 3, 9, 6. Yeah, okay. So it also just covers, right, these up to 10. Okay. So using these divisibility tests, we can make others. So although we don't have, right, and the book doesn't explicitly list a divisibility test for 12, we can see here in this example, a number is divisible by 3 and 4, then the number is divisible by 12. So this test reminds us a lot of the test for 6. The number is divisible by 6 if the number is divisible by both 2 and 3. What this example is saying is a number is divisible by 12 if it's divisible by both 3 and 4. And what did we say for 6? We said for 6 that 2 times 3. So we said 6 equals 2 times 3. And the only multiples of 2 and 3 that overlapped were the multiples of 6. That's exactly the same here. So 12 equals 3 times 4. And the only multiples of 3 and 4 that overlap are the multiples of 12. Okay, right, that makes a lot of sense. So similarly, yeah, right, 2 and 3, the only multiples they share are the multiples of 6. Similarly with 3 and 4, the only multiples they share are the multiples of 12. But let's look at a test that doesn't work here for 12. If we write 12 equals 2 times 6, this doesn't work. So you can't just pick any multiples of a number. you have to pick ones that don't have this overlap, right? Because 2 divides 6. So every multiple of 6 is also a multiple of 2. In particular, you can think of this a little bit easier as any multiple of 6, 6, 12, 18, 24, 30, 36, those are all even. So every multiple of 6 will be even, so therefore every multiple of 6 will be a multiple of 2. So this doesn't work for that reason, but also you can see that we know that 6 divides 18, and we know that 2 divides 18. But if we were to say that a number is divisible by 12, if the number is divisible by 3 and 4, but we have that 6 divides 18 and 2 divides 18. So 18 is divisible by 2 and 6, but 12 is not. By 18 is not divisible by 12. 12 does not divide 18. So this is kind of a counterexample for why this doesn't work, but it also doesn't work because every multiple of 6 will be even. So we don't have the case that the only multiples of 2 and 6 that overlap are the multiples of 12. It's every multiple of 6 overlaps there. Okay. So these are the basic divisibility rules that are kind of covered throughout section 5.1. So I haven't mentioned it in the videos for this section yet, but if you have not read the textbook, please, please, please go back and do it. This will make a lot more sense. They have a lot more examples of using the divisibility test than we're going to cover in these videos. So I recommend doing that. Oh, okay. For this example, we didn't finish if it's divisible by 11 and 12 for this example. So we'll finish that right quick. Okay, which are the numbers 2 through 12 divide 1, 8, 6, 3, 7, 2. We've done through 2 through 10. So you can see we didn't have a divisibility test for 11, but really similarly, we just divide by 11 to check if it's divisible by 11. So 1, 8, 6, 3, 7, 2, we just divide by 11. 11 goes into 18 once, with 7 left over. This goes in 6 times, with 10 left over. 103 goes in 9 times. With 4 left over, 47 is 4 times. Oof, I'll run that room here. So it's 32. So this is not going to go in evenly. This is going to be 2, remainder 10. Okay, so yeah, this does not divide. 11 does not divide 1, 8, 6, 3, 7, 2. Because, right, if we divide by 11, we get a remainder. And then let's look at 12. So remember, we just talked about a number is divisible by 12 if it's divisible by 3 and 4. So 12 indeed does divide this because it's divisible by 3 and 4. So 12 does divide 1, 8, 6, 3, 7, 2. Okay, so these are the divisibility rules for 2 through 10. Sorry, 2 through 12, essentially 2 through 12, where we have all of these tests, and here's an example, but if you need more examples, read the textbook because they have a ton there, but that is all for this video.